Alright, so in this video lesson right here, let's learn how we can solve a square root equation. Okay, and so before I get into the method of solving a square root equation, let's understand what it means by being a square root equation. Alright, so quickly, these equations that I had on the board right here are examples of square root equation. So what is a square root equation? Simply, these are equations. Again, we've done a lot of solving equations up to this point right here. The whole general goal of solving equations, you want to find the value for the unknowns, making the left-hand side equal the right-hand side. And again, you want to find the value of your unknown, making the left-hand side equal the right-hand side. But in this case right here, the reason now we call these the square root equation, simply because they involve either one square root term or two or even more square root terms here. Okay, but for our class here and at our level here, mostly we are going to focus on those square root equations where it involves exactly or only one square root term or exactly two square root terms. And those are all of the cases that we learn to handle, to solve in our class here. Okay. Alright, so now allow me to bring in our first example here to be a demonstration problem right here. Okay, and then throughout, and as I go along with this demonstration problem, I should be able to bring in the instruction of the method, how we can use that method to solve a square root equation like this. Okay, and then what I noticed about this square root equation here is that it has exactly, or it has only one square root term right here. Alright, and so now let's look at the instruction. Alright, so now let's look at how we can solve our equation here. And our equation here currently, as I have pointed out, it's being an equation with exactly one square root term right here. So let's specifically look at how we can solve a square root equation with only one square root term. The first step here is to put the square root term, the only square root term, as I mentioned, the only square root term. Let's put that only square root term on one side of the equation and all other terms on the opposite side. So in that case, with our original equation here having exactly one term, let's put that only square root term on one side and all of these other terms, meaning non-square root term, to the opposite side. And so I noticed that our square root term here is already itself on the left hand side being a positive term. So I'm going to decide to leave that here. So I put the square root term on the left hand side. That means those other terms, those terms other than the square root term, let's bring them to the opposite side. So in this case right here, I'm going to need to add x to both sides and subtract 2 from both sides. So our resulting equation will become the following. Square root of x plus 4 will equal to x minus 2. And this is exactly what it meant according to step 1 by putting the square root term on one side and leaving all other terms on the opposite side. Okay. The next step of our instruction, let's square both sides of the equation. And so now before I'm doing what's instructed in step 2 right here, allow me to bring in a property with equality right here. So what allows us to be able to do step 2 according to the instruction is that anytime we already had an equation or an equality, from this given equality, taking the square of the left hand side will also equal taking the square of the right hand side. And this is the reason why now from that point on, people around the world famously refer to this property as squaring both sides, or square both sides of our original equation, of our original equality. And that's why we had that in this particular step 2 in our instruction, that we can square both sides of our equation. Okay, so with our equation at this point, the square root term on one side equals to some x minus 2 on the right hand side. Okay, let's square both sides of our equation, meaning the entire left-hand side, the square root term x plus 4, I am going to square that left-hand side, take the square of that left-hand side entirely. The right-hand side being the x minus 2, I am going to take the perfect square of that, okay, according to the instruction. All right, and so now let's look at the impact right here. After squaring both sides right here, we're going to produce the following. The left-hand side, from our lessons about square roots, we have learned that now if we square a square root expression, we will result in the expression inside the root now, but without the square root. Or another way of saying it, we have been famously saying that the square operation will now cancel the square root, leaving it behind just the expression without the square root and without the square. So the left-hand side comes out simply just x plus 4. So anyone learning in this video lesson here should be already very familiar with how we operate with square root. Okay. The right-hand side here, we can just simply take our time foiling out that perfect square right there. It is a perfect square, so at this time of our learning right here, we should be able to either do it with a fast way by expanding out easily that perfect square, or we can just think of that as multiplying out with foiling as x minus 2 foiled out with x minus 2. So you take your favorite route for that. I'm going to just simply come up to the next step as quickly as x squared minus 4x plus 4. And so I took that as a perfect square, but you can also take your time foiling out that those two identical factors to get to x squared minus 4x plus 4. Okay, this is now what we call the resulting equation after squaring both sides of our equation. All right, and so now with the resulting equation right here, let's go ahead and take some time solving that resulting equation. And this is exactly what's being instructed in step 3 of our instruction. Step 3 of our instruction says, let's solve the resulting equation after squaring both sides of the original equation. And so now I recognize this equation now as a quadratic equation simply because it involves a square terms of the unknown right there. Okay. And at this point, anyone learning the video lesson here should be familiar with all different methods of how you can solve a quadratic equation. So it is required that you know how to operate with square root, and also required that you know how to solve a quadratic equation with any of the methods that was already taught. And so now I'm just going to first always rearrange my equation here into the standard form. So what I'm going to do, I'm going to subtract the constant term from both sides. And since my x squared term was already on the right-hand side being positive, I decided to keep it there. So that means I'm going to bring all terms to the right-hand side, making it a standard quadratic equation. Minus x from both sides. My resulting equation here is x squared minus 5x, because these two terms here are combined. 4 and minus 4 got canceled out, and those cancel out. So that's equals 0. Okay, so our equation here in standard form, the easier way to read it, x squared minus 5x equals 0. Now, when we get into solving this, it's just me, I personally choose to do factoring with this equation. So I'm going to factor this left-hand side here as x in product with x minus 5. But this is just my choice of approaching this quadratic equation. Anyone viewing the lesson here should be able to do that with other methods, whichever that works at your comfortability. So now my factor product here is x times x minus 5 equals 0. That means we're gonna end up with the factor x equals 0, or the factor x minus 5 equals 0. And now we have produced for ourselves two sub-equations. This equation is already at its dead end, where we have found one possibility, x, the unknown for this equation, must equal to 0 to have equality satisfied. Or on the other hand, the unknown can be found by solving this little equation, x minus 5 equals 0. I'm adding 5 to both sides, now making it x equals 5. So as another possibility, x equals 5 will make this equation here equal 0. But now what we have done here is that we found the solutions of the resulting equation that I have done a lot of work on. Okay, and the resulting equation here came out from squaring both sides of our equation that was originally written. So everything I was doing on the board there was just now the work of step 3 right here, where we were solving the resulting equation. But now in step 4, we need to check to discard any solution that gives a negative value inside the square root term. So this is a very important step right here. After solving that resulting equation, we have ended up with 2 values, but I'm not going to rush into concluding these 2 answers here as our solution to the equation at the beginning yet. We need to make sure that any of the value we have found for x, when we substitute it back into this equation, it won't violate with that critical requirements that the expression inside the square root got to be positive or the 0 only. Okay, or another way of saying, we've learned from our lessons about square root that square root can only operate on non-negative number. So any of the values that we have found here, x equals 0 or x equals 5, we better ensure that any one of these meets that requirement that when substituted into the equation, the square root term must be the square root of a non-negative value. Okay, and so now I'm quickly going to check as following. Square root of 0 plus 4, because now when x equals 0, square root term becomes a square root of 0 plus 4. That is square root of 4, which is the square root of a non-negative value. This is passing. Okay, now the same way right here, when x equals 5 right here, the square root term becomes a square root of 5 plus 4, which is the square root of 9. Okay, and so now in this case right here, this is also checked. All right, so now we can conclude that these 2 values are our solutions to the original equation. So in order to have the square root of x plus 4 minus x plus 2 equals 0, we have found 2 answers on one possibility. X equals 0. We'll make left hand side equal to right hand side. Or as another possibility, x equals 5, we'll make the left hand side equals the right hand side. Alright, so now allow me to bring in another demonstration problem where I call that example 2. And in this problem right here, we're asked to solve the equation here for x. So our unknown for this equation is the x. But what's in this equation here is that we are now having 2 square root terms. And so let's look at some instruction about how we can solve a square root equation where there are exactly 2 square root terms. Okay? Alright, so in what I have pointed out about the example 2 that we have just now written on the board right there, then what we're getting into here is that we're about to solve a square root equation where we have 2 or exactly 2 square root terms being involved. Okay, so this is the instruction for how we can solve that square root equation with 2 square root terms involved. As the first step here, we want to separate the square root terms by putting 1 on each side of the equation. Let's separate the square root terms by putting 1 on each side of the equation. Our equation here at start is having 2 square root terms. So now according to the instruction, let's separate the square root terms so that 1 is on each side. Okay, and so this term here is already a positive term, so I'm leaving it here on the left hand side by the way it is. But I'm going to purposely bring that square root term to the opposite side. But we are doing that by adding that square root term, square root of 3x plus 2 being added, will be added to both sides of the equation. Okay, and so the resulting equation comes out as following. Square root of 4x minus 3 is to equal. Now the entire square root terms here appears to be opposite term. They cancel on the left hand side, but that's how it's leave out with square root of 3x plus 2 on the right hand side. And that's exactly what the instruction meant by separate out the two square root terms by putting one square root term on each side. Okay. And now once we have separated the square root terms by putting one on each side of the equation, the next step now is to take the square of both sides of the equation, or for short, we just square both sides of the equation. And so in that way, now I am going to square the left hand side, which makes it 4x minus 3 in the square root, then square. The same way, the same thing I'm going to be doing to the right hand side. Square root of 3x plus 2 is going to be square. Now that we have learned from our lessons about square root, squaring a square root expression will cancel out the square root, or we'll make that expression here appears without the square root. And the same way with that, squaring on the right hand side, squaring a square root here will cancel out the square root symbol, leaving behind just the expression inside. Okay, so the resulting equation is going to be as following: 4x minus 3 equals 3x plus 2. All right, so now this is the resulting equation after squaring both sides of that earlier equation. All right, and so now this equation here is very simple for anyone who views a lesson here to solve. Okay, so I'll take my route, and you can take your own route of solving it. So I decide to bring that 3x term to the other side, because subtracting it from both sides right here, we bring that to the left hand side, and combining like terms with the whatever already on the left hand side, we will make a positive x term. So that's now leaving it x minus 3 equals 2. And everything here is at this point, the resulting equation here is a linear equation. I'm adding 3 to both sides, making it x equals 5. And so everything I'm doing here is exactly the steps that was indicated by step 3 from the instruction. So the step 3 here is to solve the resulting equation after squaring both sides of that equation. And so now after solving the resulting equation, once again similar to example 1 that I've done, similar to the kind of equation, this kind of square root equation that has exactly one root term right here, we definitely want to check to eventually discard any solution that gives a negative value inside the square root term. So just be aware that our equation here originally has two square root terms. We follow our steps to solve and brought it down to, and found out that the equation is supposed to have as a solution x equals 5. But before we making that final conclusion, we have to check to ensure. So among one of our square root term is 4x minus 3. But now when x equals 5, this term will become 4 times 5 minus 3. 4 times 5 inside the square root is a 20, minus 3 is a 17. So we have square root of a positive 17, which is completely okay for a square root. Remember, the only critical requirement for a square root is that the number inside the square root must be a non-negative value. So we have reached, when x equals 5, the expression inside the square root came out being 17. So that's making it square root of a positive number, which is completely good. Now, but don't forget, x equals 5 must also be substituted into the other square root term right here. 3x plus square root of 3x plus 2. Okay, and so that square root of 3x plus 2 will equal to square root of 3 times 5 substituted in for x, okay, plus 2. And this square root expression right here will come out 3 times 5 is a 15 plus 2 is another 17. So we're looking at square root of 17, which is also passing the requirement in a sense that we're taking square root of a positive number. And so now we can go back and conclude our final answer here. This is the solution to that original equation. The unknown has to be equal to 5, and this is the only value for the unknown that we have found. X equals 5. will make that left hand side here equals the right hand side. All right, so now allow me to bring in one more example right here where I would like to demonstrate a special case right here that we need to learn how to handle specifically. And let's now call that example 3 right here. So we want to solve this equation here for the unknown value x. Okay, and so observing this equation here, yes, it's an equation, it's a square root equation that has 2 square root terms. So it's similar. Okay, but now the situation is a little strange, it's a little special right here, so allow me to really get into it, and then we're gonna see how we can handle the method. But let's just now apply the instruction that we have learned right here. So first step is to separate the 2 square root terms by putting 1 on each side. We have already reached that. Okay, and so now in that way of how I explained it, that means we have already passed the first step in the instruction, separating out the 2 square root terms where we have one square root term on each side of the equation. And so now we're ready for the next step right here. The next step among the instruction is saying that we square both sides of our equation. So allow me to rewrite the equation. Okay, so with this equation now having the 2 square root terms being separated on the 2 sides right here, step 2 says that we have to square both sides. So the left hand side after being squared, that's looking like that. The right hand side after the square is looking like that. Okay, and now really getting into squaring both sides. The right hand side after being squared, the square is going to cancel with the square root, making it 4x plus 1, free from the square root. The left hand side here we need to take some time following it out carefully. Okay, or at this time, at this video lesson right here, anyone learning from it should be fluent enough to be able to quickly FOIL out this special product, a perfect square here, so that we can bypass the traditional foiling. So allow me to do the quick method right here. So after foiling out using the quick formula right here, then we have square root of x minus 2 all square plus 2 times 3, making it 6 times the square root of x minus 2, and plus the square of 3, which is 9. So after squaring both sides of the equation, we have the following resulting equation. The square root of x minus 2 all square plus 6 times the square root of x minus 2 plus 9. One further step for this resulting equation. The square on that square root term right here will cancel the square root sign, making it x minus 2 plus 6 square root of x minus 2 plus 9. And that's making it equals to 4x plus 1. And so now I have observed that my resulting equation still has one square root term remains. But now at least the resulting equation has reached to that equation where we have learned some experience from example 1 earlier, where we can now treat this resulting equation here as the resulting equation as a square root equation with one square root term. Okay, and so I'm going to now go ahead and follow that same instruction. So now I'm going to emphasize that in this step 3 right here, when we are solving the resulting equation, following steps 1 to 3, when we solve a square root equation with only one square root term may be needed. And that's exactly what I was saying earlier on the board. And so now let's look back at that instruction we've had earlier when we were solving a square root equation with only one square root term. Let's put the square root term on one side and put all other terms on the opposite side. So this equation, my square root term has the coefficient 6. It's already a positive term. Let's leave it here on the left hand side. These are all the non-square root terms, or I so call that all of the other terms. Let's bring them all to the opposite side. So now I'm going to subtract x from both sides. I'm going to add 2 and subtract 9 from both sides. add 2, and subtract 9 from both sides. The resulting equation will come out as following. 6 times square root of x minus 2 equals 3x minus 6. Okay, and so now we are ready for solving this equation according to the step, that kind of equation where we have only one square root term. So now I'm going to square both sides of this equation here. Okay, and that's how I write squaring both sides of our equation. And now after squaring, the left-hand side comes out as easy as we will square the 6, making it 36. And the square root term here cancel with the square, making it just now x minus 2, but free from the square root. I'm going to take my time squaring out this perfect square right here, making it now 9x squared minus 36x plus 36. Okay, and once again, anyone can see this here as the foiling of 3x minus 6 times 3x minus 6. Or there has always been a fast formula to go from a perfect square into this trinomial setup right here. Okay, but now at this point, with this resulting equation here, I'm going to continue solving that. Left-hand side here, I will distribute that 36 for each term, making it 36x minus 72 equals 9x squared minus 36x plus 36. All right. And now I'm going to rearrange the terms here by subtracting 36x from both sides, and as well as adding 72 to both sides here. The reason I did that, I recognize that our current equation here was a quadratic where the x squared term, the square term is already on the right hand side being positive. So I decided to bring all terms to the right hand side, making it a standard equation. So the standard quadratic equation comes out as following. 9x squared minus 72x plus 108, all of that equals 0. This equation here has a common factor of 9 throughout 3 terms on the right-hand side right here. So let's divide all terms by 9. That will make it 0 to equals x squared minus 8x plus 12. And now we can easily solve this quadratic equation here with whichever the favorite methods that anyone viewing the lesson should be comfortable with. Okay, and using any of your favorite methods right here, this equation should come down to 2 solutions. X equals 2 and x equals 6. Okay, so we have found 2 solutions. But now before we make the final conclusion about the 2 solutions, we must substitute each one of our found solutions into the original equation to ensure that we won't violate the critical requirements for each of the square root right here. And that critical requirement is that we cannot have a negative value inside the root. Okay. So with this narrow space of my board right here, when x equals 2 that we found, let's check for that. Substituting that into the first term right here, making it square root of 2 minus 2 equals the square root of 0, which is passing the requirements. The same x value right here, x equals 2, substituted into the other expression on that right hand side. 4 times 2 plus 1 is the square root of 9, and 9 was a positive value, so that square root passes the requirements right here. So x equals 2 now is one legally accepted solution. Let's check for x equals 6 that we have found. Okay, when x equals 6, for the first term right here, square root, that square root term there becomes square root of 6 minus 2, which is square root of 4, and 4 inside was a positive number. This expression here passed the requirements. When x equals 6, substitute it into the other expression, making it 4 times 6 plus 1 all inside the square root, making it the square root of 25. And the 25 inside the square root is a positive number, so it also passes. So x equals 6 also passes the two square root term requirements. And so now in that way, our final answer is concluded to be x equals 2 being one solution, and x equals 6 being another solution. So what it says here is that in order for that equation to be true, or in order for that equality between the left side and the right hand side here to be true, x as one possibility may equal 2, or x may equal 6. Any of those two values will make the left hand side equal the right hand side.